Welcome to the On-Premise IT Roundtable podcast, the only show that dares to be both on topic or on premise, and sometimes on location or on premises. Each time we meet, we bring together a group of IT luminaries to discuss a single topic. In this episode, the premise is storage, and specifically that, it takes more than hardware or software. You need both in order to build the future of storage. Before we begin, let's meet who's on the panel today.
Hi, I'm Justin Warren. I'm the founder and chief analyst at Pivot9 Analysts and Consulting.
Hi, I'm Marc Staimer. I'm the president and chief Dragon Slayer at Dragon Slayer Consulting.
And I'm Justin Emerson. I'm a technical evangelist here at Pure Storage.
And I'm Stephen Foskett, organizer of Tech Field Day and publisher of Gestalt IT. So this is a subject that's very near and dear to my heart as a storage maven. It seems like for years we've seen storage oscillating back and forth between all software and specialized hardware. But yet, over at Pure, Justin Emerson, we've seen some striking of a balance. Is that really what Pure is going for?
Absolutely. I think the future of storage really has to be hardware and software. For a long time, hardware appliances had been the norm. And then we started seeing more and more software features enter into storage, and storage became more intelligent. And now we see also other paradigms of platforms where they will be, say, software-defined storage entirely and sort of abstract away all of the underlying hardware. But at the end of the day, everything does have to run on hardware. And the most efficient way to do that is to have both hardware and software working together. And that's sort of the approach that we took at Pure.
Yeah, it's an interesting one where people try to say that storage is like, is it hardware or software? It's like, well, it's always been both, hasn't it? I mean, we can't really do anything just with sand that sits there and doesn't have any smarts that goes into it with software. I suppose it's more about where on the dial have we had the lever, really. Do we have levers and dials? I'm mixing metaphors a bit too hard there. But is it mostly hardware, or is it more appliance based than what we see, where it's software that you get separately and then you put it onto hardware of your own choosing? That's what it feels like to me.
I think it comes down to the level of integration that we're talking about. If you talk about most storage systems, they integrate down to the drive. Some will actually integrate, like Pure, down to the NAND itself, which is below the drive level. But in reality, it's a level of integration. If you're talking about software-defined storage, it still needs, as you pointed out, hardware to run on. You always still need the hardware. So it's a level of integration. What is the value of that integration?
And I think it's really been a journey over time because, Justin, your comment, like if you go way back, way back, and you're thinking about, floppy drives or tape drives or whatever, there was very little software built into the storage. And in fact, you could do crazy things like, one of Wozniak's original inventions was, well, instead of having the floppy head move track by track by track, let me just accelerate it and let it fly over to the point where it needs to go. And you could do that because you could literally control the hardware with the software, but more and more over time, there becomes a bigger, greater distance between those two things, the underlying physical characteristics of what you're doing and the software that you use to control it. There's just been more and more layers of indirection put in between. So it's kind of like, yes, there's always been software, but kind of the interface between those two has become more distant over time, or has become more complex. And so the question is, where does the software end and the hardware begin, or where does the compute end and the storage begin?
Justin Emerson, I think what you're talking about there is what we're seeing today in most storage systems is that you have system level integration, system to system, not system to media. And that's a big difference. And then when you talk about software-defined storage, again, what you're talking about is integrating multiple systems together to create a single entity. Correct me if I'm wrong on that.
If you look at modern storage systems, they're really complicated compared to traditional, back in the day where you had a small number of, say, spinning disks. Now you have systems on top of systems on top of systems because each level is its own kind of level of intelligence that needs to manage what's going on under it, because the systems have built up in complexity over time.
Yeah, that it's layers of complexity. Turtles all the way down. I mean, at the moment, really, storage is slow memory, and we've gradually added all of these layers to make it a little bit easier for programmers to access slow memory to keep stuff hanging around long enough because we don't have magnetic core anymore. But each time we add another layer, there's all of this additional complexity and abstractions that leak a little bit between each other. They don't quite expose all of the layer underneath because we don't want to know all of the stuff. But then that makes it actually not anything much like what's really going on. And then so by the time we got to Flash, we had all of this heritage from back when we started using platters and spinning stuff that just it runs around in a circle really, really quickly, and then we have read and write heads that skip over the top of platters, which is insane. Like, the fact that this even works is just mental. But we got used to talking to it and pretending that this insane chaos wasn't running around inside one of these drives. And then we got to Flash, which is a lot closer to core memory again. Like, we're talking to NAND, which is still deeply magic, and trying to figure out, okay, well, why are we running through 19 different abstractions that were designed for something which was spinning Rust, but now it's actually just silicon again? Why do we have all of these translation bridges? And I mean, Pure has one of the things that I like about the way that they approach stuff is that because they have that tight integration, they can throw away a lot of those abstractions and go, you know what, we don't need this. It's Flash. We can ditch the heritage we don't need anymore and just do the stuff we do. And then you can get rid of a lot of the complexity by just throwing it away.
What you just hit on, Justin Warren, is that in reality today, what we have is that complexity. That complexity is the issue. It makes things more difficult to troubleshoot. It makes things more difficult to tune. It makes things more difficult to extend the life of. And as you were pointing out, in the case of Pure, they get rid of a lot of that. But let me give you an example why that benefits by getting rid of a lot of that complexity. If you take a SSD, a flash SSD based on NAND today and utilize it, you're not going to get the statistics of which cells went bad. You're not going to know exactly which cells went bad because they over provision and they're replacing it if a cell goes bad. If you've eliminated that aspect, that software where you can see the cells themselves, you can over provision less, therefore reduce your costs and simplify your ability to troubleshoot. I mean, it's the whole issue of complexity. We're seeing more complexity even in cloud services. There are cloud database services today that actually abstract the cloud infrastructure, which is an abstraction from the hardware. So it's abstraction on top of abstraction on top of abstraction, which makes troubleshooting just a nightmare.
Yeah, the abstractions are great when they work for you.
That's true.
The benefit of abstractions is that it helps make the underlying layers replaceable. It makes them interchangeable, right? But what happens when you have underlying infrastructure or underlying layers that are interchangeable is you have to sort of target the lowest common denominator, which is, in the case of, say, disk to flash, throwing away a whole lot of the advantages of flash in favor of hiding its complexities. Justin, you said, why are we doing this? Well, it's because there's decades of file systems and applications and operating systems that are all built up around assumptions that a block storage device is a contiguous set of logical block addresses, and those map in some way or another to sectors and tracks in a byte addressable way. And the biggest change in that aspect in the last 30 years has been the move from like 512 byte sectors to 4K sectors. Outside of that, it's really been a disk world. But in the last decade, with the introduction of Flash had to build all of these structures to essentially masquerade as disk to avoid breaking everything. And so the innovation of that we made was, let's take that layer of illusion or that layer of indirection and let's up level it to a system level instead of a drive level, because it still needs to happen at some point if you want applications or operating systems to talk to storage the way that they always have, whether that's a block protocol or file or object. But the higher up in the stack you can do that, the more efficiently the stack underneath it becomes.
Yeah, LUNs need to die. Like, why do we have LUNs? Um, it's just an insane idea. But as a programmer, like most of the time, I don't deal with LUNs anymore. Who deals with LUNs? Why do we even have this? Most of the stuff that we deal with is interacting with that higher level abstraction. So we buy storage from a vendor. The only people who need to care about what happens between the storage array interface and everything, down to the media, should be the vendor. Like, if it's working, I shouldn't need to care whether you use LUNs, whether you use file, whether you use some esoteric new thing that only you have created. Ideally, I shouldn't need to care, because all I do is I put my photos onto this thing and then I pull them back using some other protocol usually. Unfortunately, it's often something like iSCSI, which brings LUNs back again.
That's true, but if you are, say, for example, deploying something like software-defined storage, you have to care deeply about all of those underlying complexities, because now that's become your problem as opposed to the vendor's problem, right?
Yeah, I don't want it to be my problem. I want other people to have problems.
From a vendor point of view, it's a philosophy. And you could have the philosophy, I just want to use commodity server hardware and be able to run my stored software in there, and so that I can use off the shelf, white box, cheap parts. And then it's, again, from the user point of view, totally transparent. They don't see that. They're just not interacting with the parts, they're interacting with the software. On the other hand, philosophically, if you abstract and actually remove a lot of the multiple layers of system controller within that, you have more control. Ultimately, you can potentially have more performance, not always, but you can potentially extend the life of the hardware. You can make it more reliable, more available. So again, it's a philosophical difference, and there's no right answer as to which one is better ultimately.
Yeah, I try to shy away from saying that this is best, or this is the way it should be done, or that there's a right answer. There usually isn't. There are optimizations for particular circumstances. I mean, as a classic consultant, it depends. But once I know what you're trying to do, then we can try to match that with a solution that actually it fits the shape of the hole that you're trying to fill. If trying to say that there's only one possible tool for all problems, like it doesn't. It's never really been true. But what we do need to do, and vendors need to get good at this as well, is to very carefully say, this is who this is for. We're not trying to solve the problem for everybody, because not everybody has this shaped problem. What we want to do is say, we've made choices for the way that we design our products that mean that they are optimized for people who are working in this way. And then we get away from the head-to-head stuff, which is really confusing for customers, where vendors are saying, oh, we can do everything for everybody. And now it's on. I mean, it keeps me employed, because part of my job is to go and explain what the vendors really mean. But it actually makes it harder for customers to choose or to find the thing that actually suits their problem. And that's what we're really talking about, is how do we find the right optimum level between how integrated to the hardware do you want to be, where on the hardware software continuum are you, and then what is that useful for?
Yeah, I think reasonable people can come to conclusions that are opposed in this case, right? There are some scenarios where a software-defined solution might make sense, especially when that underlying level of interchangeability becomes super critical to something. And speaking from the vendor perspective, the last thing I want to do is have a customer get a solution and then find out it doesn't solve their problem, and now you have an unhappy customer. So I think it's really important, like you said, to be clear about what your solution is solving for. And I think when it comes to determining what that is, I think having an understanding of the efficiency profile in addition to other things is really important. Mark, you brought up removing all of these layers in between. Something that people should probably think about if you look at a solid state disk, there's potentially gigabytes of DRAM in that SSD. Justin, you talked about we're back to doing everything in silicon, but DRAM and flash are fundamentally very different. Like one's byte addressable and one's not in the same way. And we have to have, in order to maintain that illusion in the drive layer, all of this memory and other stuff in there. And so that stuff burns power, it adds cost. And so where on the continuum that you sit, you also have to think about, well, what does that do from an efficiency standpoint from the top to the bottom? And that's true whether you're talking software defined or otherwise.
And Justin, I agree with you, but again, that's more of a vendor issue than a user issue. From a vendor point of view, it's going to make your equipment more reliable for you, and it's going to make it easier to troubleshoot, and it may reduce your cost. From a user point of view, totally transparent. Unless you're improving their life in some way, specifically, better performance, more services, something that affects them that they actually relate to, it's, why should they care? And that's what it comes down to. So what? Why should they care? Ultimately, what problem are you solving by doing it? From you, I see the problem. For the users, it will depend on the problems you're solving, as Justin Warren just pointed out. So I see the pros and cons. Don't get me wrong. I see a lot of pros in hardware integration on a deeper level. And I also see there are cons involved too. And from the commodity point of view, I see the pros and cons as well. It's going to come down to the specific workloads, problems that you're solving.
So I want to follow on what Marc was just saying and kind of bring it back to this question of like, what does the user really get or the buyer really get from this? Because there you can make an ideal situation where you can have sort of an optimum combination of hardware and software. But what is the buyer? How does the buyer benefit from that? And I think that it really has to be about kind of passing that efficiency on to the end user, to the buyer. In other words, either in terms of power efficiency, space efficiency, cost efficiency, performance efficiency, there has to be some way in which the buyer gets more than they would otherwise in one of those axes in order for this to all matter. Because otherwise, I mean, to be honest with you, all of us have seen over the past, decades in storage, companies that just built ridiculously over provisioned, over engineered systems and just threw hardware at the problem. And that probably isn't the right answer, but it has resulted in some pretty good systems, even though they were overdone. So how does the customer
Stephen,
benefit?
can I interject something on that for a moment? If I were to look at what Pure is doing, they are reducing the amount of hardware internally. They're reducing the amount of power required internally. Green is becoming essential in the data center today. It's essential in the cloud data center, in the hyperscaler. It is really important. It's getting more important all the time. But another factor is waste. The less moving parts you have in the system, the less waste you have over time. All those are really important, both in the manufacturing aspect and the disposal aspect in the long term. So I can see from a philosophical integrity point of view, long-term view, has immense possibilities. I can also see where it has possibilities where you can offer potentially other storage services that you could not offer in the past. But again, it's going to come down to what problems you're attempting to solve.
Yeah, and that's I think the key that vendors sort of miss is you've got to create a link between what you're designing for, what is the problem you're trying to solve, and how you do it, but not obsess over the how so much. What you're doing is providing evidence to support the claims that you're making so that they're more credible. So you say, "Oh, we are more efficient at this." It's going, "Cool. Everyone says that. So why should I believe you?" So if you can explain how you achieve this and say, well, we've removed all of this extra componentry because of the way that we do it. If that makes sense, like if you can say we have these facts and we link them together in a logical chain of argument. I know it's old fashioned, but bear with me. If you do it that way, then your customers can evaluate whether or not those claims are credible. And okay, I'm trying to do X. You say that your thing is good for X because of the way it does this. I can then look at that and evaluate. Okay, that makes sense to me. And even better, if it has some testable claims in it where I can say, okay, you say it's going to be more efficient or it's going to consume this much power, I can go and put a meter on it and I can go and figure out, it's going, does it actually do what it says on the tin? And that way you can actually figure out, okay, yes, what you've said about how you do it does actually achieve that result. And then we know why you've achieved, why are you matching up with the problem I'm trying to solve?
And Mark, your comment earlier before Stephen jumped in, it depends on how you define user, right? If you're talking about an application user versus or a consumer of the storage versus a person who is managing it or deploying it, et cetera, they get very different experiences. And so it's absolutely true that a user like an application owner, what they see expressed by the storage is very different than the particulars that the person managing it sees. And if you come back to, well, what does that add to the user experience or the customer experience more broadly? Um, there, all the things that Stephen mentioned, these are big improvements like performance, for example. If you can write less to the NAND, that doesn't just have benefits in endurance, but it has benefits for performance. Because if the slowest thing that you can do with NAND is program erase cycles, which it is, the less of those you do, the more time you're spending servicing I/O. And the best the best I/O is the fastest I/O is the one that you don't do or don't have to do. And so the less of it you do, the more performant the system's going to be overall. And so the way that the technology, the how, like Justin talked about, the way the how is expressed in the customer experience is a plethora of different things that all can really matter, not least of which is power. If you build over engineered systems, which is one approach, you do end up missing out on certain other things. Every piece that you add is more parts, more power, more complexity, and that built up over time can become a major burden. And it's, you can't cheat physics. Right? You can't undo the power usage with magic.
And Justin Warren made a really good point on this. And you're right, you can't cheat physics, but basically what you're talking about, Justin Emerson, is the proof points. The proof points are the how you accomplish your performance. But performance can be achieved in multiple ways. And ultimately, it's how you articulate what performance means. And when you articulate performance, you're articulating it in as far as time to market, time to active analytics, time to decision making, time to market. I mean, there's a whole bunch of things that come from improved performance, but articulating that in the aspect of where it benefits the organization using it is more important than how you get there. How you get there is your proof point.
Yeah, I'm not sure about there's no magic involved. Tricking sand to think and trapping electrons into little tiny jails is kind of so that we can store cat pictures. It's like, why? What? How does any of this actually, why does this work? Makes no sense.
And then to write over, you have to destroy it. Yeah, minor details.
Yeah. It's just the more you learn about how this stuff actually works under the covers, once you start going past these abstractions and looking into all of these layers of complexity, you rapidly discover that you probably shouldn't have ever lifted up that rock. Leave it to the vendors to deal with.
Well, what Arthur C. Clarke said was any sufficiently advanced technology is indistinguishable from magic. So if you think about it, it's not magic. It's just, but if you showed it to somebody, 30 years ago or 40 years ago, they'd probably call it magic. I think if you looked at the phone in your pocket and showed it to somebody even 20 years ago, they'd think it was it was some joke that you were playing on them, and there's got to be some like projector somewhere that's making this look like it is. But the complexity underneath those systems, yeah, it's the vendor's problem. But understanding those levels of complexity, when we lose the ability to understand those levels of complexity, we start to lose the ability to leverage them intelligently. And if we start assuming that these levels of indirection or these systems in between are magic and aren't of a particular design that make a certain set of assumptions and strategies, then we can end up building systems that don't leverage the layers underneath efficiently because it's just a complete black box.
Yeah, it's fine. You can ignore what's happening under the abstraction as long as it's working. It's when it doesn't work that everything breaks down. And usually that's when you've discovered that your assumptions about how this stuff actually works are completely wrong. So that's when it's reliable, it's handy. And again, this I think it comes back to how close to the hardware do you want to be? How far away do you want to exist with your abstractions? And I mean, that depends upon what you're trying to do. If I'm a programmer who's writing code, I don't really want to have to care about that low level of detail. Whereas if I'm the system architect who's designing a storage farm that needs to exist and live for 5 years, I'm going to care about stuff like maintenance cycles and how often does this break, and when it breaks, in what way, how long does it take me to replace them? All of that operational maintenance stuff starts to become really, really important.
We used to have a term for it called RAS, right? I know I'm dating myself: reliability, availability, and serviceability. It's an old term, but it's still true. And so when you have more complexity, you have more things that can and likely to break. That's what it comes down to in a nutshell.
So now that we've had a chance to discuss it a little bit, I think it's time to return to our premise. Considering all the things that we've discussed, can we say that we agree that the future of storage isn't purely hardware or purely software, but a little bit of both? Marc, let's
Yes.
start with you.
No, I'm going to elaborate on that. But yes, it is. It is a combination of both, and it depends on what you're aiming for. Again, we're going to go back to what problem you're solving, but ultimately, you can't develop software in a vacuum, and to have hardware that doesn't have software is irrelevant. It doesn't work. So you always have to have both. But what it comes down to is how you're integrating that software with the hardware and what problems you're solving in doing so. That's it in a nutshell.
Yeah, I'll agree, but I'm going to agree in a slightly different way, which is always more fun. So yes, it depends. Classic consulting, but I don't think this is a problem that can be solved. I think it's a tension to be managed. I think the where we will end up on this continuum will change over time, and I think that's actually more important. Being able to adapt to the changing world around you so that you can move on that dial from being more hardware centric to being more software centric, depending on what you're trying to do, because what that is will be different. Particularly if you're in any organization of any size, like you're not just trying to do one thing, you're generally trying to do multiple different things. So you're going to have to be able to solve multiple problems or address multiple challenges at the same time. And that mix will change. So being flexible and adaptable, being able to move around on this continuum, I think is what we really need to be looking for.
And I think that's a great point. I think Pure Storage has gone through that same journey, right? We began with consumer SSDs and then moved in one direction and sort of pulled the tension more towards uh, our own hardware. But of course, that requires software to make work. And so I think the future of hardware has to be both. Excuse me, the future of storage has to be both hardware and software. And the trick then becomes, how do you build those systems in intelligent ways that not only present a better user experience, but also more efficiency and performance, et cetera, that are things that matter to customers.
And from my perspective, as someone who's watched the storage industry for many years, it occurs to me that really the best solutions, the most optimum solutions in terms of pretty much any scale you care to pick, are the ones that have a good grasp of the broadest spectrum, all the way from one end to the other. In other words, if you've got a system that truly is intelligent and integrated all the way from the hardware all the way up to the client, that it's generally going to give you a more optimized solution, whether it's in terms of performance or efficiency or reliability. An engineer once told me that an SSD is just a really small storage array. And that has stuck with me for many years. And it's so true. We are just building, storage arrays out of storage arrays out of storage arrays. We're building file systems out of file systems out of file systems. And if we can kind of cut through some of that and bring some intelligence to that, I think it really does give us a more optimal system. So before we go, if you've been interested in this, where can we connect with you and continue the conversation? Justin, Warren?
Yeah, you can find me, find our website at pivot9.com, pivotnine.com, and on Twitter at pivot9.
You can connect with me at marcstaimer@me.com or on Twitter at Chief DS.
And if you want to connect with me, I'm at Justin Emerson on Twitter, or you can reach me at LinkedIn, Justin Emerson, and Pure Storage website is purestorage.com.
And as for me, I'm Stephen Foskett at sfoskett on most social media services, and you can hear me here on the On-Premise IT podcast or on our weekly news rundown at gestaltit.com. So thanks for listening to this edition of the On-Premise IT Roundtable podcast brought to you by Pure Storage. If you enjoyed this discussion, please do give us a rating or review in your favorite podcast application, and do share this episode with your friends. This podcast is brought to you by Pure Storage and by Gestalt IT, your home for IT coverage from across the enterprise. For show notes and more episodes, go to gestaltit.com/podcast. Thanks for listening, and we'll see you next week.